after pondering the hole right there, this one right here in particular, that hole right there is supposed to be 7/16, and you can see it's 1/2 inch. That 7/16 just goes right in there, and that was the cleanup hole on that. So we're going to repair it. No reason whatsoever to scrap an engine block just because of a bad thread. Now, with that said, I could put a that's cleanup thread right there is 1/2. So I actually could drill everything out that goes on to that stud there to a 1/2 inch, make a couple of bushings, and I could upgrade that to 1/2 inch. Also, I could put a thread cert in there and step that down to 3/8 from this 1/2 inch thread that's here, and then make a oversized bushing to go in the rocker there for the fuel pump, and go at it that way. Or we could put it over there on the milling machine and put one of them there thread lock thread certs in there, you know, several different brands and configurations that will work here. But let's put this engine block over yonder on that there milling machine, and we'll come back after that. Now that we're over here on this Grizzly G1007, that's a model number on this old milling machine. I've got a 33/64 drill bit in the collet there, 1/2 inch collet step down drill bit. And what we're going to do, and this right here could be one of any of the different brands and different types. Helicoil, there's just a myriad of different brands, and I use them all at any given day. The next one I might put in might be a helicoil, but this one right here is I think they call that a key lock thread repair insert thingamajig. And what's happened here is that's supposed to be a 7/16 stud that goes in here for that fuel pump. And it was stripped out, and it kind of appeared to me that somebody had cleaned it up to a 1/2 inch thread. It was wallowed out quite large, so I did go ahead and run a 1/2 inch tap in there, and the thread looked pretty decent. But with this thread repair insert thing, this hole needs to be enlarged to this 33/64 drill bit, and then tapped to a 9/16 12 coarse thread, so that this will screw down in there, and then that'll put us back to the 7/16 internal thread. And each year you do put that, we'll do it, but this little thing here drives them down in there and tightens it up. But this is what we're going to use here. And the internal thread here on the stud is a 7/16 14 thread inside that right there is what we're going to end up with. So without further ado, and probably should kind of talk about this a little bit, as there's no blueprint to distances, and this hole is already oversized, and I do have some other blocks that I could and one of the reasons that I've got this in the milling machine, and I got it all leveled up, this surface right here completely trued up with the mill, and this, when I screwed a 1/2 inch stud in here and put the square to it, it was not a it was askew is the word I'm looking for. It was not straight with this housing, and it should be. And that's the reason I got everything fixed tight. All the table and everything is locked, and the engine is steadfast and true and level. So I'm going to drill this out and then tap it all in this setup. Now, without any measurements to go by, just using the best measurement that I can come up with, like center lines to here on the housing cover, and then from here to here, and then just going by this hole that we have here, thinking it will be within some thousandths. So without further ado, let's get on with this project. And I do have the mill running about 180 RPM there. It's quite slow. It's the slowest speed on this mill. Cast iron. Not going to use any lubricant. And you can see about how deep we went there in that casting. It's about a little over 1 inch. And looking at the hole from the sideways right there, it's a quite nice hole. And it's what this drill bit here is only, what, it's 516 thousandths, I believe, is the size on that. Take that out. We'll remove that drill bit right there and collet. I'm gonna put a different size collet in here, and then we'll thread that hole. I'll make that change. Probably should get them chips out of that hole because it's not a through hole down in there. It's quite deep, and I don't see any threads in there. So I think maybe it was not off center as much as I kind of thought it would be. Just use a magnet, get them shavings out of there. 3/4 inch collet yonder in the mill. The 9/16 drill bit. Should be a good, true, straight hole. Got a little pressure on the quill there, just slightly, and that is a taper tap. Get down and get it almost done, then I'll switch over to a bottoming tap. Keep a little pressure on the not no down pressure here, just enough to keep it in true. seems to be cutting quite well. Keep it in mind to advance the quill down a little bit so that it don't leave the tap holder. I'm going to let's extract that and look and clean out the shavings. Oh yeah, I believe we'll be all right on this one. And that is one of the advantages of using this type insert thread repair thing, is you can use a normal size tap as compared to some of the other thread systems that requires a special tap for each size thread. I'm going to switch over. I think I have bottomed out on that tap with such a long taper on it as what I'm talking about. See, the threads don't start maybe, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, at least 9 threads before you get to a full thread. So we'll switch over there at that bottom and tap. Okay. And about 9 threads down, it got tight again. And the collet, the drawbar, I just have it enough tightness on the drawbar to keep the collet tight onto the end of that tap holder. And it seems to be working quite well. Then the question again is why, and I believe we bottomed out. So let's bring that up out of there and give it a look-see. And the question again is, you know, why did I not just get a different block, you know, out of oh, that looks really good. And the reason is if I didn't have half of the McCormick-Deering parts in the state of Arkansas, as most engine people would only have the one block that they was going to rebuild, then they would not have the option of another block. So that's the reason that we repairing this, is it's just a normal repair. Just, you know, do what we're doing here. Real nice looking thread right there, and the insert. Screw right in there, down to We'd like to have it a little bit below the surface, and they do make a tool to put these in there. I've just not used to have one. So that's about one half of a thread below this mating surfaces here. And the tool that you drive those pins down to lock it in is this tool right here. Now I'm going to take it out of the, I'm gonna move the table down there before I set them, but that's the way that works. It's just a little guide pin, and when you knock that down there, it knocks those pins down. So let's move the table down. We're finished here. There's nothing more we can do. And while we're on while we're still bolted down to the table here, let's just go ahead. It's a good solid surface. Let's just go ahead and drive those pins. I'm gonna hold it. And that's all they are to installing a thread repair insert. A key lock, I think, is what it's referred to. We'll bring it over, we'll get it back on the rotating table over there and carry on. I may add that it's not 100% necessary by no means. Many of these thread repair inserts of whatever brand is installed with just a hand drill. And I did entertain the putting this one in, drilling the initial hole with a guide block. I did entertain that idea, just using a guide block and a hand drill. But you know, being got the milling machine here at hand, this has worked out really good. So I think we saved another one. Just get that fuel pump on there. Let's put that side cover on now.